Hello students, in the previous class we have seen the line spectrum of hydrogen, and there we have seen that many series of lines were obtained. Among that, the 5 series of lines are written over here, that is Lyman series, Balmer series, Paschen series, bracket series and prefund series. Okay. The N1 value for the Lyman is n equals to 1 and the N2 value will be N1 plus 1. That means the N2 value will be, the starting one is 2, then 3, then so goes on. For Balmer, the N1 value is 2 and the N2 value will be 3, 4, 5, 6 and so on. And for Paschen, it is N1 value is 3 and N2 value will be 4, 5, 6 so on, and for bracket N1 value equals to 4 and N1 value 4 and N2 value will be 4 plus 1, that is 5, 6. And in the same way, the prefund series, the N1 value is 5, then the N2 value will be 5 plus 1, that is 6, 7, 8 and so on. Okay. Now, one more scientist, he gave one of the general formula which can be used for all the 5 series of line. Okay. The formula is, that is wave number, or we know that wave number is the inverse of reciprocal of wavelength. So, it is equals to 109677, this is the Rydberg constant, and the bracket 1 by n1 square minus 1 by n2 square centimeter inverse. Okay, this is the formula. Now, we will see, using this formula we are going to calculate some numerical questions, find out the numerical questions. Okay. Now, see that question. The question is, calculate the wave number for the longest wavelength transition in the Balmer series of atomic hydrogen. So, here what is given to you? Yes, the question is, the series given is the Balmer series. Okay, the series given is the Balmer series and you are asked to find out the wave number. That means the same here, wave number equals to 109677 bracket 1 by n1 square minus 1 by n2 square centimeter inverse. That means here you are going to find out the wave number. Okay. And series, that means n1 value, we know that for n1 values already I am written here, and for Balmer series the n1 value is 2. Okay. So, what will be the n2 value? So, what is given here? Longest wavelength. जब याद रखना, जब longest wavelength है तो energy difference जो है बहुत ही कम होना चाहिए. That means the energy difference should be the nearest energy one. The nearest N2 level is the third one. Okay. So, here the N2 value will be 3. So, we will put this value here in this Rydberg expression, that is 109677 by 1 by N1 value is 2, so it is 2 square minus N2 value is 3, so it is 3 square. Okay. When we will solve it, we will be getting the answer 109677, yes, 1 by 4 minus 1 by 9. So, when we will solve this one, centimeter, yes, unit, remember it is in centimeter inverse, centimeter inverse. Okay. And when we will solve it, we will get the answer, that is 1.5233 into 10 to the power, yes, 4 centimeter inverse. Okay. This is the answer for finding out, this is the way to find out the wave number. When what is given to you? Series of line is given to you, here Balmer series is given. So, here in the place of n1 we have to use the value 2 and the longest, then that means the nearest one 3. Okay. This is the way calculation. Here you will be finding, you should find out the LCM, that is 36, then 9 minus 5, 5 by 39 minus 4, that is 5 by 36. Then you will calculate it, this answer you will be getting. Okay. Now, come to the next, that is the Bohr's model of atom. Okay. The Bohr's model of atom. This is the most important theory, and this topic is the most important for the NEET exam also and for the class exam also, for the school exam also. Okay. Now, let us see one by one what is the Bohr's model for atom. Bohr has given the 4 important postulates. So, the first postulate given by the Bohr is an electron. We know that this atom in the center part, that is the nucleus, that means it is made of a proton and neutron. Proton carries the positive charge, neutron no charge. So, we can say the nucleus has a positively charged center, and in positively charged center they revolve around the positively charged center, electron revolves around it according to Bohr's. Okay. And this circular path he called this circular path as orbit or energy level or stationary state. Okay. These orbits, this is the first orbit, this is the second orbit, and this one is called the third. These all are the orbits. Okay. These all are the orbits. This orbits, remember, it has the fixed energy and fixed radius. That means it remains constant. And this theory eliminates one of the drawbacks of Rutherford model. Remember that what Rutherford has said, when the electrons revolve around the nucleus, the electron should collapse. But in this case, in the Bohr's theory, it is given that the orbit's energy remains the same. So, there is no questioning that the electron is going to collapse. Okay. Now, we will see the one more thing. Yes, before going to the second postulate, let us see these orbits, they are designated as K, L, M. In the lower class already you have learned this one, and numbered as 1, 2 second energy level, this one is a third, and so on, many energy level, n level also is there, present there. Okay. This is the first postulate. First postulate, what it said, that the electron revolve around the nucleus in a circular path, and that circular path has constant energy. Okay. And that is called orbit, that path is called orbit or energy level. Okay. Now, come to the second, that is the second is the, as long as the electron remains in the particular, that means if I am considering that the electron is present over here, if it is present there, it is not going to lose or gain energy, it remains constant. Okay. That means it is stable. Okay. But if I am going to add the energy, I am going to give the energy to this electron, it is going to jump to the higher energy level. And if I am removing the electron, for example, if electron jumped over here, if I am removing the energy, that means it emits the energy, it will come back to the ground state. Okay. This is the second postulate said by Bohr's. Okay. Now, let us see the third postulates. When the according to the third postulates, when the transition occurs between two stationary states that differ in energy, the wavelength of the radiation absorbed or emitted can be calculated. That means, when the transition occurs between the two energy states, we are able to calculate what? Wavelength. If we are able to calculate wavelength, means we will be able to calculate the frequency, because both are inverse of each other. Okay. Now, let us see how. We know that according to second postulates of Bohr, what it said? According to second postulates, yes, when any electrons emits energy, it is going to come from higher energy level to the lower energy level, and wavelength of the radiation emitted by an atoms, remember, wavelength of an element of the electrons or the atoms depends on the difference of the final energy and the initial energy of the orbits. That means, here we know that E is represented by the formula according to Planck's constant h nu. Okay. Now, instead of this one I am replacing nu by c by lambda, then here the value will be h c by lambda. That means, h c by lambda will be equal to the difference between the final energy transition, final state, and the energy of the initial state. That means, E final minus E initial. Okay. Here h c by lambda or h mu is equals to E final minus E initial, and h c by lambda is what? It is the energy of the radiation, okay, given out by the electron, and E initial and E final is the energy of that electron orbits where the electron is being revolving. Okay. It is means it is orbiting around that nucleus. Okay. Now, let us see one example. let assume that an electron jumps from E3 energy level to E2 energy level. So, what will happen? It will give out the radiation, and this can be calculated by using the wavelength. Okay, that means here the final, if the electron is means it is emitting radiation from moving from E2, that means the higher level is what? Emitting means from the higher level to the lower level, that means it is present in the third level, it should move towards the E2 level, that means the second level. Here final is E2 and the initial is E3, and this difference is given by Hc by lambda. Using this one, if the energy difference we know it, how much energy it is emitting, and using this one, because this one is constant, it is called the Planck's constant, and this one is the velocity of light, this one is also constant. So, using this we can find out the radiation emitted by the given electron, that is 1 by lambda will give you, or lambda will give you the value. Okay. This is about the one of the thing about the third postulates. Okay. Now, one more thing, in the third, with the help of third postulates, we will be able to, the Bohr has explained the emission spectrum. In the previous class you have seen what is emission spectrum. There in the emission spectrum you have seen only the few visible light, most of the region was dark. So, how it happens? Now, the third postulate tells that the difference of the energy means here E final minus E initial can be given as delta E. Okay. The difference in the energy can be given as the expression for wavelength, that is Hc by lambda. Okay. We have seen in the first postulate that each state has fixed energy. Okay. In this, that electron is revolving, that state, that means that orbit is fixed, and there we know that if orbit, that means orbit means what? Energy level. Okay. The orbit is what? That is the energy level. It is fixed. If it is in K level, it is fixed. Here it is L, it is the energy, this energy level also fixed for the given electron. So, if energy is fixed, their value will also be fixed. If their value is fixed means what we are taking here, the energy difference. The energy difference will also be few. There will be few energy difference because the energy level is few, their value is few, their difference will be also few, and their value will also be, the difference in value will also be few. So, here we will be getting a few fixed value, and if any quantities has few fixed value, that quantity is called quantized. Okay. That is why we can say that here the wavelength which you are obtaining, that wavelength of emitted spectra, the spectra we have seen, there we are getting few colored line, visible line. Why? Because here the wavelength of emitted spectra is quantized. Here we will be get a few values, few. So, we see only few lines in emission spectra. This is one of the main important postulates given by the Bohr. In the fourth postulates, we will see that an electron can move only in those orbits for which its angular momentum is an integral multiple of h by 2 pi. How? Let assume that electron is revolving around the nucleus. The radius between the electron and the nucleus is equals to r, and the mass may be m and velocity is v. Then the angular momentum is taken as mvr, and which is equal to nh by 2 pi. Okay. Here it is the value of n is an integer which is equals to 1, 2, 3 and so on. Here the value will not be getting in the decimal form. This shows that because here we are getting the orbiting value, this value of the orbit, this shows that there are only few fixed orbits where the electron moves, because here we are getting only few fixed value. So, the orbit is also a few. Now, next see the achievements. Okay, now we have seen the four postulates of Bohr, that is, for the first one is the electron, yes, revolve around the nucleus in a circular path. The second one, that it is the path of the electron where it is orbiting, it remains constant, it is not going to change. And the third postulate is when the energy transition occurs, we can calculate the wavelength or frequency. And the fourth, that is the angular momentum mvr is equals to the integral multiple of h by 2 pi. Okay. Now, let us see the achievements of Bohr's theory. The postulates given by Bohr, what are their advantage? Okay. The first one, that is the Bohr's theory has explained the stability of atom. How? In the first postulate it was said that, what it was said, that the electron revolve around the nucleus in a fixed path. That means its radius is fixed, its energy is fixed. If it is fixed means it is stable, that electron is stable, that atom is stable. If we are going to give the energy, then it will get excited and it becomes unstable. Okay. So, the first postulate explains this stability of an atom. One more thing for the stability, remember, if we talk about the stability, we should talk about the energy. Okay. If lesser the energy, more will be the stability. This I will explain it in the next achievement. Okay. So, remember, stability means the energy where the electron is revolving, that path is constant, that means that energy remains constant. So, the electron is stable. Okay. Now, come to the next second achievement, second advantage, what Bohr has said, the Bohr's theory has helped in calculating the radius, velocity, that means different parameters we can calculate, radius of the electron and the radius of the electron revolving here, and the distance between this we can find out, the velocity of the orbiting electron we can find out, the energy of the electron in hydrogen atoms we can find out. Especially this Bohr's theory can be used only for one electron species. One electron species means where hydrogen or He plus or lithium 2 plus, not for helium and lithium it cannot be used, because this is not a single electron species. Single electron species means containing one number of electron. Okay. Now, let us see one by one how to find out what are the parameters, what are the formula for finding out the parameters. So, let us see the first one, that is finding out the radius. Let us assume, we are assuming that an atom is present in a nth energy level. Okay. An atom is present here, an atom is present, for example, if I am assuming that it is present over here. Okay. I am assuming that it is in the nth orbit. Okay. Now, the radius can be written as r, remember the radius be r, this one z is the atomic number of the atom. Okay. Now, how to write the radius of the electron or the atom present in the nth orbital? It is equals to 529 yes into n square by z Armstrong. Armstrong, remember 1 Armstrong equals to 10 to the power minus 10 meter. Okay. This is the formula for finding out the radius present in nth orbital. Okay. Now, let us see for velocity of the hydrogen or one electron species can be calculated by using the formula 2.18 into 10 to the power 6 yes z by n. Okay. Meter velocity unit we know it is meter per second. Okay. This is the way to find out the radius as well as velocity. Okay. So, using this formula you can compute. For example, if a question comes, for example, calculate the radius of an element of an atom in orbit, orbit is given equals to 2, okay, and for it is given for helium plus. Find out its radius. If the orbit it is present in second orbit, that means the value of n is 2 and the species which is given is He2 plus. So, how to find out using this formula? Rn, here Rn value we know that it is present in which orbit? So, the helium it is present in second orbit. So, I am going to write here it is 2 and the value of n is, here it is yes n square means 2 square 4 and z value, because it is one electron species means the value will be 2. Okay. Now, 4 it will get cancelled. Okay. Here we will be getting 0.529 into yes 4 by 1 will be cancelled, then 2 Armstrong. If you will calculate it, you will be getting the answer 2 9s are 18, 2 2s are 4, 1 5, 2 5s are 10, yes. Here the answer is 1.05, the Rn value, the radius value, the distance between the radius and the nucleus is 1.058 Armstrong. In the same way you can find out the velocity. Here in the velocity you have to write the value of z here, yes 2, and here the value is 2. That means 2 will be getting cancelled. This one is very easy. Here the value of z is what? Because the atomic number of hydrogen at z represents the atomic number. Okay. So the value of helium is 2. And here it is present in which orbit? It is present in second orbit. So the value will be the same. The velocity of He2 plus will be 2.18 into 10 to the power 6. So in this way you can compute using this formula, finding out the radius and finding out the velocity. Let us see how to calculate the by using Bohr's theory, how we can calculate the energy in the nth orbital. Okay. Now En we know that the value of En, it is given by minus 13.6 into z square by n square electron volt. Okay, it is in electron volt. So if I have to convert, here electron volt, I am going to convert it into joule. So I know that 1 electron volt equals to 1.6 into 10 to the power minus 19 joule. If I will put the value over here, multiply this one, I will be getting minus 2.18 into 10 to the power minus 18 z square. Okay, I am rubbing this one. Z square by n square. This is the formula of the energy of the electron in nth orbital, which is this one is in electron volt and this one is in joule. Okay, this formula. Now things about this formula, if you will notice that here you will find that the energy is directly proportional to atom z square, whereas inversely proportional to the orbits. Orbits means n square, inversely proportional. So here if you will see, अगर E1 का value देखेंगे, we will find that in electron volt मैं ले रही हूँ, that is 13.6 into 1 square, because for hydrogen the value of Z atomic number is 1 and n square value, since the n1 value n is equals to 1, here equals to 1 square. So the answer which we are getting here is minus 13.16 electron volt. Okay. If we will take the case of, in the same way if you will calculate for E2, minus 3.4 electron volt. Okay. And here what you will notice that when we are moving from E1 to E2, what is happening? Here the value was minus 13.6 electron volt, here it is minus 3.4 electron volt. What is happening? The energy is being increasing, because the negative value, it is being increasing. That means when we are moving from first energy level to the next energy level, the energy increases. Now let assume that we are moving towards the infinity, then we will be getting the value nearly equals to 0. That means when we will get the value, for example for infinity, if we are getting the value nearly equals to 0, that means that electron which is revolving around the nucleus, it is not under the influence of nucleus, it is free from the influence of nucleus. Okay, when it is too far, okay, that means that electron is too far. So now we will see what happens to the energy gap. Okay, here we have seen the energy between E1 and E2. Now let us see the energy gap between En and En plus 1. Okay. So first one E1, already we have calculated, the value was in electron volt minus 13.6 electron volt. If E2 value I am calculating, the answer comes to be minus 3.4 electron volt. In the same way E3 value I am calculating, means here the answer is minus 1.15 electron volt. Okay. And E4 value, which is equals to, yes, it is equals to 0.85 electron volt. Okay, this is the value E1, E2. If I am see the gap between these two, that means the energy difference between these two, I am getting the answer. If I subtract it, I am getting the answer, that is 10.2. If I am subtracting these two, here I am getting the answer 1.89. Okay, and here in this 0.7. So here what you are observing, if the value of n increases, the gap is being, yes, it decreases. Okay, it goes on decreases, and if it moves on down near to moves on E5, E6, E7, E7, E8, we will find that the energy levels become nearly equal. That means the discrete energy level going to merge. They move continuously. Here we can see that we are getting the continuous energy level. That means in the spectrum what you are observing, in the rainbow, there we are getting a continuous spectrum because the energy of one merges over the other. Okay. Now let us see one more advantage of Bohr's theory, how the Bohr's theory has proved the Rydberg equation. Rydberg expression already in the first we have explained, how we will see it. Okay. So what is Rydberg equation? Rydberg's formula, I know that Rydberg formula is, yes, it is 1 by wavelength equals to, or mu bar equals to 109,677 bracket 1 by n1 square minus 1 by n2 square centimeter inverse. This is the formula. Now we will see how the Bohr's theory has proved this formula. Okay. So when we know that when the light emits radiation, it moves from higher level to the lower level. Okay. Now when it moves from higher level to the lower level, we will find, for example, if it thinks that if the initial level is taken as, if the initial level of the orbit be Ni, Ni is the initial orbit and the Nf is the final orbit. That means the electron is being moving from initial to the final. Now Ni value will be equals to, yes, according to energy difference we know that what is the energy difference? Energy difference, that means delta E equals to, yes, delta E is given by Hc by lambda. Okay. That means 1 by lambda equals to, 1 by lambda equals to delta E by Hc. Okay. Now using this formula we can, if you are putting the value of energy difference and Hc value, we will be getting that answer. Now let us see how. Okay. Here, because the initial state was, initial orbit was, the electron is present here in Ni, so I am going to calculate the Ni one. So Ni equals to, okay, it is equals to, yes, minus 2.18 into 10 to the power minus 18 z square, yes, by, because it is in the Ni level, so here I am writing Ni square. So E in the electron present in the fth orbital, energy of the electron present in the fth orbital is written as 8 into 10 to the power minus 18, yes, z square by Nf square. If I will subtract the 2, that means final minus initial. Okay. That means delta E equals to E final minus E energy of the electron present in the initial. Okay. So here I will get the value, here I am getting the value, I am going to rub this one, let us see how. Okay. E final minus E initial. Now going to solving it here. Yes, E final means what? Minus 2 point, that means delta E equals to minus 2.18 into 10 to the power, yes, minus 18 z, yes, square by Nf square. Then minus, remember difference, that means minus, and here again negative sign is there, that means minus minus positive. We will be getting 2.18 into 10 to the power minus 18 z square by okay, and yes, n because it is for the initial level, and 1 square. So here I am taking the common, that is 2.18 into 10 to the power minus 18 z square. This one is common. Now the answer is this one, 1 by ni square minus 1 by nf square, okay, and this one is in joule. Okay. Now this is the delta E value. If I will put the value over here of delta E, that is 2.18 into 10 to the power minus 18 z square by ni square minus nf square, nf square, okay, and divided by Hc. Hc is what? Hc is Planck's constant 6.626 into 10 to the power minus 34, and C is 3 into 10 to the power 8 meter per second. If I will put the value, and you will find that if you will calculate it, you will be getting this value. Okay. So the Bohr's theory has proved the Rydberg, explained the Rydberg's एक्सप्रेशन. ओके, आज के क्लास में हमने देखा कि बोर्स थ्योरी ऑफ हाइड्रोजन मॉडल एंड उसके एडवांटेज समझ, होप करती हूँ कि आपको आज का क्लास समझ में आया होगा. और अभी क्या है, एक असाइनमेंट जो है, एक क्वेश्चन नोट कर लीजिए.